What is L'Hopital's rule? So, suppose we have the following case. The limit of x as it approaches a of f of x over g of x equals an indeterminate form, such as 0 over 0 or in plus or minus infinity over plus or minus infinity. And there's some more. So, what this rule says, and a can be any real number or infinity or negative infinity. So, what the rule says? It says that this limit, the limit as x approaches a of f of x over g of x, is equal to the limit as x approaches a of f prime of x divided by g prime of x. This is the rule. This is very useful. So now I'm gonna do some examples so you see how useful it is. Let's look at this limit. Limit as x approaches 0 of sine x over x. As you can see, if you plug in 0 here, then it's 0 over 0, which is an indeterminate form. So if we apply L'Hopital's rule, we find that the limit as x approaches 0 of sine of x over x is the same as the limit as x as it approaches 0 of the derivative of sine of x, which is cos of x, over the derivative of x, which is 1. So, cosine of 0 is 1, and 1 over 1 is 1. Now, let's do a second example. The limit as x approaches infinity of e to the x over x squared. If you look at this, both e to the x and x squared approach infinity. So it gives us this indeterminate form. So what we do is the same. Apply L'Hopital's rule and take the derivative of the denominator and all the fraction. So the derivative of e to the x is just e to the x, and the derivative of x squared is 2x. Now, again, both of them approach infinity. So what we do is apply the L'Hopital rule another time. You can apply it as many times as you want until it reaches a limit that does not have any indeterminate form. So again, the derivative of x to the x is of e to the x is e to the x. The derivative of 2x is 2. This does not grow, but this approaches infinity. So infinity over 2 equals infinity. That is the answer. Now let's look at a third example. This example does not have an indeterminate form like this too. Has another one. Has an indeterminate form of infinity to the power of 0. So we can use L'Hopital's rule again, but a bit differently. So our limit is the limit as x approaches infinity of x to the power of 1 over x. You can see that as x approaches infinity, the power here becomes 0 and this becomes infinity. So it's this. So, what we will do is say that, well, we're not going to answer this at the moment. What we will do is say that x to the power of 1 over x equals y. Then we're going to take the natural log of both sides. So natural log of y equals natural log of x over 1x. We bring the power down, so natural log of y is equal to 1 over x times natural log of x. Now, we take the limit of this. So, the limit as x approaches infinity of natural log of x over x. Both of these approach infinity, so it's indeterminate form. Apply the L'Hopital rule and find derivative of natural log of x is 1 over x. Derivative of this is 1. So, as this increases and goes to infinity, it just becomes 0. Now we note that e to the power of natural log of y is just y. So now what we do is we see that the limit that we were trying to find at the start, this, the limit as x approaches infinity of x to the power of 1 over x, is just the limit as x approaches infinity of e to the natural log of y. We defined y to be this. And you can see that this is the same thing as e to the power of the limit of x as it approaches infinity of natural log of y. And here, we know what this is, because we found it before. It's this. And this is equal to 0. So it's e to the 0, it's equal to 1. And that's it. Here is the rule again. Bye.